Good morning, everyone, and thank you for joining our breakout session. My name is Hannah Ragoza, business partner on the Market Insights team, and I will be facilitating our session today. I'm joining you this morning from the traditional, ancestral, and unceded territory of the Musqueam, Squamish, and Tsleil-Waututh nations, and I want to extend my appreciation for the opportunity to live and work here with my family on this shared territory. Thank you for joining us this morning for a 45-minute session on climate change and technical safety in BC. Before I introduce our topic and speakers, I just want to review a few housekeeping items. Many of you are probably well versed with Zoom and have attended many meetings and webinars by this point. For those who may not have, I'm going to cover just some basic tools that we'll be using today. By default, a webinar is view only, so this means that you do not have access to mics and cameras. If you do have a technical question and you need assistance, please use the chat function. Simply click the chat icon at the bottom of the screen and type your question into the chat panel and we'll reach out directly to you. Alongside the chat function is the Q&A button. Please use this function if you would like to submit a question about the presentation. We'll not have time during the session to answer all questions live, but all questions and answers will be shared at the end of the session on our engagement platform, Engage at Technical Safety BC. We'll be using Engage to share updates on our topic today, and so please make sure to visit this page and register for topic updates. Today's presentation will be recorded and portions of the event will be shared on our website. With that taken care of, I'd like to start our session. Today, we will be discussing low carbon technologies and safety system risks. We will then have a roundtable discussion with our guest panelists, followed by a Q&A period. Feel free to submit any questions throughout the presentations using the Q&A function. I'd now like to welcome our first presenters, Coral Buitenhuis, leader of Climate Action and Sustainability, and Christian Baudry, manager of Safety System Risks.
Thanks, Hannah. You actually pronounced my last name correctly, which is very hard to do. So as Hannah mentioned, I'm Coral Buitenhuis, leader of Climate Action and Sustainability at Technical Safety BC. So we know our climate is changing, and we know that this creates many different safety risks to technical equipment. From flooding to wildfires, heat waves to landslide, we now need to consider climate change impacts in the design, installation, maintenance, and decommissioning of technical equipment. The global threat of climate change has also created a set of international climate agreements, as well as federal and provincial climate targets to reduce greenhouse gas emissions. In order to meet these global, national, and provincial emissions reduction targets, there's an urgent need for technological innovation. We're seeing advances in nearly all of the technologies you regulate, especially in the built environment and transportation sectors. From hydrogen fueling stations to electric vehicle chargers, from battery storage to carbon capture and storage, technological innovation in response to climate change is entering our day-to-day. As a safety regulator, our role in climate change is threefold. First, we must take steps to reduce our own greenhouse gas emissions as an organization, as Catherine mentioned earlier today. Second, we must understand the safety risks that climate change creates for technical equipment, and then take steps to manage these risks. Third, we need to respond to provincial efforts to reduce greenhouse gas emissions by facilitating the safe adoption of low carbon technology. For us, this means understanding the new technologies entering the market so we can support the development of safety standards and regulations, help our clients to gain the skills they need to safely install and maintain these technologies, and help asset owners and the public to adopt these new technologies quickly. It also means understanding climate impacts on new technologies and taking steps to build climate resiliency into the safety system. I'm now going to pass it over to my colleague, Christian Baudry, to talk about safety system risk and climate change.
Thanks, Coral. Hi, I'm Christian Baudry, manager of Safety System Risk here at Technical Safety BC. And so what is safety system risk? Well, safety risk involves the risk of injury or loss of life, damage to property, or failure of technical systems that can negatively impact society in some way. And the safety system is really the collection of the things that Technical Safety BC does, like overseeing safe installation and operation of technical systems and equipment, issuing permits, licenses, certificates, and working with industry and the public to reduce safety risks. But it also includes the role that you, public and industry, play in designing, installing, and operating and maintaining technical systems and equipment according to code and regulations and in a safe manner. And so what is the link to climate action? Well, as Coral mentioned, our involvement in climate action involves two areas of focus. The first is that Technical Safety BC is looking at how a changing climate can impact technical safety. And the second is that we're looking at how technologies that we regulate impact the climate and the role that all of us can play to reduce BC's greenhouse gas footprint. So on the first point, where climate change can impact technical safety, we're working to understand climate models in the ways that the effects of a changing climate, like more frequent or more extreme flood events or wildfires, may impact safety of the technologies that we regulate. And we're also looking at working to understand the vulnerabilities of these technologies and the vulnerabilities of the safety system and the ways that we can build resilience into the safety system so that a changing climate doesn't increase technical risk. And on the second point about how technologies that we regulate impact climate, this really means in part playing a role in supporting innovative and emerging approaches to meet the province's climate action goals, while building resilience to maintain technical safety in the face of a changing climate. So today we'll hear from several panelists about innovative approaches to catalyzing a shift toward low carbon technologies and reducing greenhouse gas emissions in the province, and how we all can help to make a difference. We'll also explore the impacts that those technologies may have on the safety system and what Technical Safety BC is doing to understand and reduce those impacts. So with that, I'd like to welcome our guest panelists to join us on the screen, please. So today we have Ian Well, Principal Engineer with Polar Engineering, Ryan Milligan, Gas Senior Safety Officer with Technical Safety BC, Anitra Paris, Policy Analyst with Berkeley Project Group Limited, and Monica Smuda, Energy Manager with the District of North Vancouver. Thank you all for joining us today, and back to you, Coral.
Thanks, Christian. So I now have a question for all the panelists, and I'm going to start with you, Ryan. So I'd like for you to tell us, lucky you, I'd like for you to tell us a bit about what you do, and tell us how you think low carbon technology will shape your industry in the next 5 to 10 years.
Thanks, Coral. Well, I start off, my role at Technical Safety BC is as a Senior Safety Officer for the gas technology. In this position, one of my roles is as technical support and as a technical trainer for all of our provincial safety officers across the province. Another major function of this role is in supporting our clients in meeting their regulatory requirements, even if their technology doesn't quite fit the mold as defined in the regulations. Difficulty with regulations and codes is that it's challenging to write them in anticipation of coming developments and technologies. Also, as part of this role, I get to participate in national code committees along with other regulators from across Canada. A large part of my time over the last year has been analyzing the latest versions of our adopted codes for potential recommendations for adoption. In that review, we get to look at the impacts, primarily of the impacts to public safety, and then also look at the economic impacts to industry and to the public and the potential climate impacts that those codes might have, or more importantly, how they can support climate initiatives. Interaction of gas technology equipment and climate change has been a discussion at all levels of government in codes and standards committees and within Technical Safety BC, as it should be. And as the climate impact has become more and more at the forefront of driving development of gas technologies, these systems are having more of a major role in reducing the carbon footprint and greenhouse gas emissions of our technology, which over the next 5 to 10 years, we're going to see major advancements in these technologies, and we're working to be prepared for those advancements.
Thank you, Ryan. Ian, you're next. Same question to you. So a bit about what you do and how you think low carbon technology will shape your industry in the next 5 to 10 years.
Great, thanks, Coral. Honored to be here, by the way. I'm excited to hear from other panelists. It's not very often that I get to talk about green energy. A lot of the time I have to kind of sneak it into my other presentations. So I appreciate the opportunity to be able to do this. So when you look at green energy, there's kind of two ways to look at things. You can either capture it like you talked about, or you can stop it from being emitted. And Polar doesn't really work on the capturing side. We stop it from being emitted. And so what we do is we work with our clients to say, okay, you're currently burning a lot of natural gas in your large building. So whether it's a airport, a hospital, a school, recreation facility, those are our clients. And so we work with them and we say, okay, how can we turn off your natural gas boilers and pull that energy from somewhere else? So we'll pull it from the air, from the lake, from anywhere else. And then we partner with people like yourself from TSBC to make sure that we're building safe systems. So that's generally what we do. I also have to give a shout out to all the engineers that work at Polar, because they're all super passionate about green energy and really smart. So that's the people we hire, and that's the people I love working with. So I'm excited to be on the panel.
Thank you so much. Monica, you're next. So tell us a bit about what you do and how you think low carbon technology will shape your industry in the next 5 to 10 years.
Hi, thanks everyone. Monica Cemeta, District of North Vancouver. It's the other North Vancouver. 5 areas with the same name. Who knew? I do energy management. So I manage the energy used by our corporate operations. So that's our own buildings and our own fleet. I focus on buildings partly because of my background in building envelope work and building automation, but also because they're half the emissions of the corporate operations. So it's been a natural place to focus. And as Ian mentioned, people are often surprised at the fact that so many of our emissions come from not moving assets. So we use a strategic approach, and that ensures that we're not just adding eco bling, for instance, to an inefficient building. So just because a technology is printed on a green label potentially, or works great in another climate or environment, it might not be the right thing. So we focus on making sure our buildings are as efficient as possible. Some of those things are very low tech, building envelope sealing. Weather stripping is a miracle product. Don't knock it till you try it. But then we are looking at more advanced building automation, and also a lot of heat pumps. So that's specifically the kind of technology that does, we call it low carbon electrification. It replaces a fossil fuel burning boiler potentially with a refrigerant based system. And that is something we're actually encouraging on our community side as well. So we're actually hoping that all the single family residences in North Vancouver will be converting to heat pumps. And the number one risk we see with that is that that's a lot of refrigerant in the community. And refrigerant is actually a worse on the global warming potential scale than the fossil fuel itself. So it'd be a real shame if we were poorly installing or poorly manufacturing this equipment and having this even more harmful chemical in the atmosphere. So we really count on the safety inspectors and the installers to not only make sure the equipment is sound, but also to communicate with the operators, which in some cases will be homeowners, to make sure that the equipment is well maintained and safely operated, and also cost effectively, because again, there's not a lot of benefit to using more energy just because it doesn't also have a smokestack attached to it. So we really try to use a common sense, I think, approach with making things more efficient, and then making sure we maintain and operate it well. So thanks for the opportunity.
Thank you very much. Anitra, last but not least, tell us a bit about what you do and how you think low carbon technology will shape your industry.
Sure. Yeah, thanks, Coral. So my name is Anitra Paris. I'm a policy analyst at Barclay Project Group, and we're a project management firm that's based on Vancouver Island. We work with over 30 different First Nations that are all across British Columbia and into the Yukon. And the work that we do really specializes in renewable energy, and that's anything from hydro, solar, biomass, geothermal, and some marine energy. However, that's part of what we do. The other half is also community energy projects. And community energy plans. And a big part of that community energy plan is implementing energy efficiency, different technologies. And that's like a really easy way to bring down the emissions immediately, right? Sometimes with a renewable energy project, it can take years to see that. So it's really nice to have those very tangible, visible impacts through heat pumps is actually a really big one that Monica was just talking about. And I think where the industry is going. Some of the nations that we work with are so remote that they're still very dependent on diesel. And as the technologies continue to drop, we're actually able to look at more hybridized techs. So we'll be looking at, pairing hydro with a solar and having a battery. And that's something that hasn't really been possible before. It was still too expensive. So I think that those systems, those holistic systems, is a really exciting thing that we'll just continue to see more of, especially in remote locations. And the other aspect I'll say with that is renewable energy and these energy systems. Some of our clients really, really value energy sovereignty and being able to define what they have in their community. And I think that that's what we're going to be seeing from this as well. Yeah, thanks.
Thank you. Actually, another question for you, Anitra. From your perspective as a consultant, where are there opportunities and barriers with respect to transitioning to low carbon technologies in BC for stations?
Yeah, for sure. So it kind of just builds on what I was saying with the system and defining what is going on in their territory. So that's like the really big opportunity. Something else, though, I think is interesting. You have to be, not only are you trying to mitigate climate change, but you're going to have to be adapting to it as well. And I think that that's where heat pumps really come in as an interesting part of that, or electrifying buildings and doing those fuel switching projects, is that not only are heat pumps able to heat your home, but they can cool them in the summer. So as we continue to have hotter summers, that is going to be a really important aspect. And a lot of nations, actually, the way that they prioritize their houses is that they are trying to make those switches for their elders' homes first. So they're, and at that point, it's not just a comfort thing, it's a health thing as well. So you have a heat wave coming in, and you want to be protecting your elders. And of course, everybody should respect their elders, but for some nations, there's a handful of native speakers left that actually know their language. So at that point, it's also, it's almost like protecting cultural identity with that too. So it's very interlinked, and I think that that's where the opportunity is like how integrated those different elements are, and there's so many co-benefits. With the barriers, I do think that there's still limited access to capital, and that's really, that's part of why we exist as a consultancy, is to try to identify those different pathways and how to stack them, because it's not always clear about how you can actually build these projects financially. And then the other part with a barrier is capacity. Like, some governments within First Nations only have a couple of staff, but there's so many priorities, and it's like, how do you address all these priorities? And so that's a big part of the projects that we do as well. We make sure that we have a capacity and training aspect in all of the projects, so that we're not just there designing the projects. We want to make sure that they're there and they're being implemented properly, and that they're being operated well as well. And so, yeah, identifying a community liaison or a community champion that can really take ownership. Yeah, that's everything. Thanks.
Great. Thanks, Anitra. So our next question is for Monica. So Monica, this is a two-part question. First, what steps is the District of North Vancouver, or what steps, essentially is the District of North Vancouver taking to address climate change and to build resiliency through low carbon infrastructure? And how can licensed contractors and certified individuals play a role in achieving this vision?
Great question, Christian. Thanks for asking. Excuse me. So for our own operation, the district applies an asset management approach, and that's a financial planning tool that helps us know in advance that our equipment is due for replacement or major maintenance. Some of you would be surprised at how many organizations are surprised that boilers need replacing and how much a boiler costs. So that is our biggest opportunity. Not only is it the one time in potentially a building's life cycle to make a dramatic change in its fuel use, but it's also the most fiscally responsible, because if we need to work on the system anyway, now's the time to also improve it. So when we look to contractors and actually also the safety authorities, informing clients. So, using our model for others, informing folks of when their equipment is coming due for that type of major work and allowing them to plan will prevent the kind of emergency replacements that sometimes mean you don't have time to think long and hard about the best replacement and design a solution. And we find that having the time in advance to design the solutions really helps us find, speak about, and Anitra talked about holistic systems. So actually opportunities to recover waste heat instead of just making new heat. What else are we doing on site or nearby that we could use elsewhere? So that advance warning is something that contractors can definitely assist in, as well as the safety authority. Like I said, letting folks know that their equipment is getting to be unsafe at the point where it's well past its rated lifetime would help communicate the importance of looking at the technology and taking it seriously and planning for its replacement. So that's definitely a major element. Yeah, and that's probably the major one on our operating side. On the community side, we are asking for the same kind of approach. It's every time you have a choice. Do I take the bus today or do I drive? Sometimes take the bus. So we're not actually looking necessarily every time for a major no one should have cars type of opportunity, but it's if you have the option to use a low carbon option even once a week for transportation, for heating, to turn the heat down by a degree or two. We don't see those as transformative, but if everyone does something that's a 20% change, that's the entire community reducing its energy use by 20%. So sometimes the transformation that we know is required doesn't look the way we expect it to. And so to be open to that and to not be overwhelmed by the scale of the problem and assume that every solution is outside of reach. There are actually a lot of tiny steps to be taken, and we're trying to model those on our operation side, but then are also inviting the community through our community energy and emissions plan to replicate those small steps.
Thanks, Monica. Question for Ian. What trends are emerging in the space that you work in? And what are the promising technologies that are starting to arrive in BC? And what are the opportunities to support the transition?
Great. Good questions. I'll give a bit of a threefold answer to that. And I think I'll talk about the same thing that people have talked about before, is heat pumps. That's what Polar does day in, day out. We build really big ones for buildings. So it doesn't matter on the size of the building. And so what we do is we take energy from, say, the ocean or the air and then turn off the boilers in the building. So that's been a big emerging technology. But the big thing I kept hearing from a few other people on the panel is that capital. So the amount it costs to build these things, like, why haven't we done this for years? And you said you've been encouraging people, Monica saying in North Vancouver, they're encouraging people to put heat pumps in. But the question is, why didn't they put it there originally? And the answer is, I find often, is cost. So it costs more money than to put a boiler in. And so what Polar does is we partner with the government to get grants for our clients to install these systems. And actually, there's currently a grant that actually I should talk to a few of you about, which is the government will pay for 100% of projects for First Nations communities around BC to do energy reduction programs. So there's huge capital out there for these projects, but the important thing is to make sure that we're realizing that we're getting those for our clients. And then the last thing I want to talk about was Monica mentioned that the refrigerant inside our refrigeration systems actually is the single biggest contributor to global warming on the planet. And so what we need to do is educate our clients about, when you're putting in a new system, choose a refrigerant that's called a low global warming potential. And so that's what Polar does all the time too. So when we design site-specific heat pumps, we choose refrigerants that are much better for the environment, because globally around the world, 10% of refrigerant is released into the atmosphere every year. And so it's really important to make sure we're picking the right thing now, so 30 years down the road, we're not trying to change everything again. So setting ourselves up for success is the biggest thing. So that's what I think the biggest technology is, that we currently are building a lot of smaller heat pumps for our houses, but we're going to have to transition and build much bigger ones for our buildings. And those are often a bit harder to do and take a bit more engineering, but it's through partnerships between the people on this panel, for example, that we're able to do stuff like that. And then also making sure we're putting in the right refrigerants so that we're picking the best direction forward for everyone on the planet. Yeah, I think that answers all your questions.
Great, thanks, Ian. So my next question is for Ryan. Ryan, can you tell us a bit about what Technical Safety BC is doing in this space, and what risks or safety risks do you see emerging?
Absolutely. Thanks, Christian. So we at Technical Safety BC are working quite hard to stay at the forefront of new developments and technologies. To do this, we have to take multiple approaches. One of those is to do extensive research in the current state of hydrogen technologies, as an example. Hydrogen technologies is at the forefront of many discussions across Canada on how to reduce the carbon imprint of our gas technologies. So for both the transportation sector, for hydrogen fuel cell vehicles, and for low carbon fuel gas, whether on its own or as an additive to natural gas, we're doing an analysis of the applicable codes and standards for how hydrogen can become part of the gas technology across Canada and here in BC. Another approach we're taking is to work with designers and manufacturers of new technologies in prototype development and trial projects, which determine the functionality and market applications for their equipment. A couple of examples of this are projects we partnered with FortisBC on. The first was a new piece of carbon capture equipment manufactured just in Calgary that is added to a new or an existing piece of gas equipment, and it absorbs the carbon out of the exhaust stream from that piece of equipment. Another similar project was again in partnership with FortisBC, and it was with a manufacturer of a new natural gas powered heat pump technology. This technology combines a high efficient gas burner with a refrigeration system to provide a clean, efficient heating for residential and light commercial spaces, where performance is not as dependent on outside weather conditions as a standard air-to-air heat pump would be, and it provides a consistent heat supply to the building that it's supplying. So our role in that is to really analyze the codes and standards that would apply and identify gaps, work with the engineering departments for those technologies that are doing the work to develop standards for their equipment. Some of the challenges and risks that we're finding in the development of in the development of the codes and standards to address these technologies. For manufacturers to be able to ramp up the manufacturing and start to make these technologies available on a larger scale, there needs to be standards for manufacturing in place to ensure that the equipment meets specific quality and safety criteria on a larger scale, and codes are available for the installation of this type of equipment. Hydrogen is a great example of this. Increased demand in the last few years has really driven the development of a new Canadian hydrogen installation code, which is set to be published this year. And increased demand for hydrogen as an additive into natural gas is driving additions and developments into applicable codes and standards across the sector to address the safety concerns of hydrogen in the natural gas fuel stream and hydrogen as a fuel supply. Thanks, Christian.
Great. Thanks, Ryan. And thank you all for your excuse me. Thank you all for your valuable insights here today. And now we're going to move over to the Q&A portion of the session here. And so I'll invite Hannah to kick that off, please.
Thanks, Christian. I see some of you have entered some questions in the chat here. So we're just going to take a bit of time, but if anyone has any more questions, please feel free to continue sending them in to any of our panelists. Anitra, the first question is for you. Is biomass a fake green energy system? Could you elaborate a bit on that?
For sure. Yeah, I can talk about that one. So I think the thing that's interesting about biomass, and I don't know if anybody watched that horrific documentary that came out during COVID, painted it in a really terrible light around like burning railroad ties. And I mean, that stuff does happen, but I will say that it can be a viable, sustainable energy option if you know where the supply is coming from. So if you're pairing like a small scale biomass facility with an already existing forestry operation, it's a really great solution. It's not as easy to like ship long distances, and like that's where a lot of the cost comes in. And then the other thing I will say though is that if you take the forestry waste wood and you can compress it and galvanize it, it's actually a drop-in replacement for coal. So I know that there's a nation that has been working on something like that. So they actually send it to places that are still very heavily reliant on coal. And I kind of see it as like a good interim step before like completely getting off of coal. But yeah, so it can be sustainable, but it really depends on where the feedstock and where the supply is.
Can I pipe in? We had a biomass system proposed for one of our main recreation facilities. And just as I was starting my role at the district, and when I looked at what it was offering, and it was supposed to be local feedstock, but wet feedstock from our local tree prunings. The efficiencies were extremely low, and we'd wind up both trucking in material and trucking out a bunch of ash. And so it was an opportunity. I think it was going to provide 15% of our energy and offset that much natural gas. Yeah, and just like, nope. And I looked at the building and could see through the doors when closed, and could see the plume of steam coming out of both the boiler over there and the cooling tower over there on the neighboring arena, and said, I think we have some other opportunities to tie up this system before we look for a new source of energy. And let's just take a moment. And we were really successful in actually closing the loop, and we're actually heating the swimming pool with the arena and all of those first steps. And so our remaining amount of energy required is so much smaller that we can start looking at all sorts of new technologies. And that's where biomass, I've seen it really effectively used at a furniture plant, for instance, where they did all their steam heating with their own waste wood. And so it was on site and really clean, and they knew where everything was going. And that was a really beautiful thing to see. So if you can ever close that loop from waste to what you need, that simplifies things. But yeah, biomass, I'm assuming we can ship wood pellets all over and really make the differences we're looking for is possibly not it. So it's really it's a great question, because it's not vilifying the technology. It's about asking what your goals are and where is it coming from, and making sure you're following it all the way to the end, and finding efficiency first, usually with all renewables.
Thanks, Anitra and Monica. Monica, one more question for you. What qualifications are required to install heat pumps? How unique are the skills required to install them safely? And are new regulatory requirements needed in this area?
So I don't think I can speak officially to the licensure and actual that part of the technical side as far as skills. So what's funny about heat pumps is that a lot of residences already have them, because they're the exact same piece of equipment that are currently acting as just air conditioners. They're the exact same everything. And so the real skill is making sure it's right sized. We're finding that being the really important difference between one that will run well and one that won't. And I'm sure Ian knows this. There's a world of difference of how a heat pump performs as far as where it's most efficient, and whether that's on its coldest day or somewhere in between. And it's really subtle. And a lot of the reactions to equipment selection has been, well, we'll make it bigger and then we'll be safe, because then we'll have excess capacity. And Anita's laughing too, because that's the first place usually to find efficiency, is getting those matching a bit better, and not necessarily for nameplate size, but to where the optimal efficiency is, and getting those two things lined up. So that's a special skill. And if that's being done where a contractor is selling directly to a client, that's really important. And that's why we like to involve designers, because they're sort of outside of that sales loop and often can then provide some perspective on that. So right sizing is a really important skill. And then also, like I said, the communicating and being able to explain to people how to use them and what to look for. The risk of a thermostat cranked in either direction to its maximum heat temperature or its maximum cooling temperature. People don't actually know how furnaces work and how different a thermostat is from the dial of a heat dial in a car to a stove or an oven. They're actually, we think of them, we use them every day, and we actually don't understand that most furnaces only run at one temperature. And so when you change your thermostat, you're either making it run longer or less, but you're still sending the same temperature into the space. And so just understanding that that's all you're changing is how hot you get before it turns itself off, not necessarily whether or not that's what you're looking for. Those really basic things, and spending the time, those are the contractors I'm looking for, people who will understand the importance of installing it well. There's noise issues potentially with heat pumps, so making sure they're well positioned and well isolated from neighbors so that we don't get a backlash and have to remove them again or move them. Those really subtle, small skills are really important in that. And so as far as as regulation, I'm just hoping that the quality of manufacture is maintained to make sure, because most of the refrigerant comes preloaded and installed on the small ones. On the larger ones, we definitely are looking for contractors who have the advanced skills. They really need to be able to work on a team with the designers, because we need electrical, we need the controls contractors, and then also our building operators. So we wind up needing to make sure the contractors are good team players as well. So those are not often on the list of skills or licensure requirements, but really make the difference in a successful operation of a piece of equipment.
And I can add a few things to that too. So to install a heat pump in BC, you need to be a licensed contractor from the BC government. You need to have gone to school to become a refrigeration contractor. You be able to pull permits. So every refrigeration system that goes in, no matter how big or how small, the bigger ones require more permitting and the smaller ones require less permitting. So, but I think an important thing to realize is we keep talking about heat pumps, biomass, all that kind of stuff. And I think one of the really important things to look at in terms of green energy is we should try to use energy closest we possibly can to the source. So as opposed to bringing fossil fuels all the way over from northern BC or Alberta, the big thing I think we're talking about energy efficiencies is let's not say for an ice arena that Monica brought up earlier, let's capture energy that we're wasting over here and use it over here, because you'd be surprised that there's enough energy in an ice arena to heat about 40 houses in the dead of winter, and Polar works with them all the time. That's what we do, is doing energy capturing from one place to the other. But one thing that we're talking about with northern communities and diesel generators too, is that they have exhaust stacks putting gas out at say 250 degrees Celsius. So let's capture that, use all the heat from that, and use that hot water to heat the entire house, and just use the natural gas to produce electricity, right? So there's adaptations, and a lot of the time, myself included, engineers have this problem where we have one solution we really like and we're kind of put that in all over BC, but the problem is that you need to have hybrid systems, and that's, I think, how we're going to reduce our fossil fuel emissions, is have hybrid systems that use one system but then capitalize off some waste energy that's coming here and using that somewhere else where it's useful. So I think if you're people on this meeting are looking at ways of trying to reduce their energy, one thing they can look at is using less energy, but also trying to use energy that's closer to where their house is or their building is or wherever they're operating. And that's generally a much more efficient way of operating our facilities.
Thanks, everyone. The next question is for Anitra. The question is, if you could please speak a bit more about some of the low carbon technologies First Nations are looking at, specifically wondering if hydrogen or renewable natural gas is part of that conversation.
Yeah, for sure. Thanks, Hannah. So I can only really speak about, the clients that we've worked with. I'm sure that there are other nations that are looking at renewable natural gas, but so far the nations that we've worked with, they haven't been looking at that. But I also think it's kind of playing into what Ian was just talking about, where they are looking to make the energy and like those changes within their community, and it's like right in it, right? So I think that may be one of the reasons. If you're creating renewable natural gas, then you kind of have to feed it into the system and into, Fortis, you're probably not going to be using it right where you are. Hydrogen, though, is an interesting one. I do think that there is, Ryan can probably speak about this more, but I do think that there is interest in injecting more hydrogen, and you could be producing that with there's three kinds of hydrogen, right? So you have the green hydrogen, which is made with electrolysis, and that is from renewable energy. Blue hydrogen, which is steam methane reformation, and then you're using carbon capture to then make it carbon neutral, or the way that most hydrogen is made right now, which is gray, and that's just through natural gas, essentially. So it's a byproduct, kind of like a byproduct of natural gas is how you can think about it. So I think there is a lot of potential going forward. Like we have a lot of, and as technology continues, we have a lot of cheap electricity. So there could be more potential for green hydrogen and First Nations as well. Thanks.
I can definitely chime in to support that, and Anitra, that you're right. It's challenging with small communities to incorporate hydrogen or renewable natural gas on a small community level. A lot of the projects that are going on right now for hydrogen and for renewable natural gas, specifically from municipal wastewater streams and from landfill gas collection systems and biogas systems, they're feeding back into the FortisBC natural gas grid and by and large lowering the carbon footprint of the natural gas system across BC. So it's more of a larger scale impact than small community systems. There are opportunities for small community systems, but it's a real multi-pronged approach to reducing our carbon footprint across the province and incorporating renewable natural gas into the gas stream, incorporating green hydrogen. BC's well situated to be a leading producer of green hydrogen because of our abundance of green hydro, and hydrogen is produced through an electrolysis process. From that green hydroelectricity, it produces green hydrogen, which then can be incorporated into the system. And then, looking at opportunities for electrification where that's possible. There are a lot of parts of the industry that require high intensity heat sources where electrification is not going to make sense. So if we can look at ways of reducing the carbon footprint of the gas that they're using, or reducing the carbon output that they're putting out from their exhaust streams, those are all the different aspects of having a larger scale impact on our carbon footprint, rather than just looking at one or two particular areas.
Thanks, Anitra and Ryan. So we're gonna be moving on to our final question. For this one's for Christian. We've been talking a lot about mitigation of GHG emissions. Climate impacts are already here, for example, more extreme weather events. How do these climate impacts increase risk to technical systems, and how are we addressing the rising risks?
Thanks, Hannah. It's an excellent question. Right now, as we all know, we're starting to see these the impacts of climate change right here at home: increased wildfires, warmer, longer summers, and when you look at the projections, it's sort of continuing on that trajectory. What we're doing at Technical Safety BC is to try to really understand what the projections are for those climate implications, and mapping that across the province, and also taking a look at the technologies that we regulate and where are they most prominent, and in what ways might they be affected by changing climate, whether that is increased wildfires, changes in temperature, changes in the maximum, the high temperatures, as well as sort of longer summer, shorter winters, cooler winters, those kinds of things. And just trying to understand really what those implications are, how they could, impact the technologies that we regulate. And specifically, we've been taking a look at boilers as a first point there. And if you consider things like heat exchangers in the way that they operate with the ambient temperatures, if those ambient temperatures change, these things might not be as efficient or as effective. And so that's really looking more at the effectiveness of these technologies. But in terms of the actual safety, we're taking a close look through research that we've initiated late last year, particularly starting off with boilers and then expanding out to other technologies. So one of the pieces of focus here is, one, to understand how the climate can impact these technologies and safety, but also understand how do we build resilience into the safety system, into the individual technologies. And so that's another place where we're really looking to see what is it that we can do as a regulator to really sort of foster that resiliency sort of focus and approach. And I've had some conversations, Monica, with yourself about resilience in the actions. And the one thing that came up that a number of panelists mentioned today is, with heat exchanger systems and heat pumps, is that really you turn them on in one way, they're heaters, the other way they're air conditioners. And so as you start to see these more frequent wildfire events, if you have the ability to use air conditioning in your home in British Columbia, which at least in the Vancouver region is sort of a rarity, now you sort of protect yourself. This is more about your personal health by being able to keep your windows closed and your doors closed during wildfire events. And this is something that Monica and I were discussing recently. So we're looking at opportunities there to really support that. So I hope that answers the question.
Thanks, Christian, and thanks everyone for answering the questions. It looks like we're just about at time today, and any questions that we weren't able to answer, we will be taking back to our Engage site and answering there. That brings us to the end of our session today. Thank you everyone for attending and sharing your insights on climate change and technical safety in BC. And a big thank you to our guest panelists for taking the time to join us today. I would like to remind everyone that a recording of this session will be available in the coming weeks on our website, which you can share with your colleagues and your networks. I'd also like to remind you to please visit engage.technicalsafetybc.ca. Thank you again and have a great day.